All right, hypothesis test for paired comparisons. When we are given the information for individual values of the two sets of data, so we have store 1 and store 2, and in the earlier problems you were given the mean of the first set and the mean of the second set. But now we have paired comparisons, and that's a different sort of an animal. When you are specifically dealing with paired data, then you want to subtract each pair of data and get its own difference. So you're going to end up with the mean of the differences. So first we find all the differences, and then we're going to find the mean of those. Now, I was not able to get Alex to take this column as a data set. I couldn't load it into Alex from that column of data. I ended up having to type it in, which is not the worst thing in the world. Okay. So we got a note that the 2 stores have been comparable in the past. Just see if the improvements have made store 2 more popular than store 1. Okay, so we're comparing the mean of the store 2 to the mean of the store 1, and we want to know, here's the overall question, can the owner conclude that the mean daily sales of store 2 exceeds that of store 1? So it's important to note the way the question is asked. So the population differences is store 1 minus store 2, and so that's what they've given you in this table. This is what we load into Alex, the calculator, and then we'll find the mean of those differences. Okay. So I had to type them in, and if you type them in just with a comma in between but no space, then it accepts all of your numbers properly. And then you simply hit mean. You're just going for the mean. So see if your differences will open. This says it will, but I think I found that they did not. Click on your sample mean, record the answer. Then undo, click undo, and then click on S to get your standard deviation. You'll use these values in the rest of your calculations, okay? So you're going to get your mean and then your standard deviation off of Alex. And if you just undo, then it'll keep the values here for you, okay? For these data, our sample mean was negative 83.375, and the standard deviation was 117.253. Remember those, we'll use those in a minute. So if you notice, if the daily sales of store 2 exceeds that of store 1, then store 1 minus store 2 is going to be a negative value of the mean differences. So if 2 is higher than 1, a smaller number minus a larger number will be negative. So that's kind of an odd thing. It doesn't set well in your brain, but it does fit well mathematically. So our null and alternative, the null is going to be, the alternative is going to be that the mean differences is negative. And of course, less than 0 means negative. So the opposite of that is greater than or equal to. Remember that the null gets the hypothesis that has no equal sign, and the alternative gets the no equal sign, and the null gets the one that does have an equal sign. That's the only way you tell the difference between the null and alternative. The claim can have either sign. So you might know the alternative first from the claim, or you might know the null first from the claim. So you have to just know which one, where to put each one. The one with no equals is the alternative. The one with the equals is the null. So remember our X bar, our sample mean, was negative 83.375. Our hypothesized difference is 0 because we always hypothesize that there is no difference. Standard deviation was 117.253. Remember we found that. N was 8. Your degrees of freedom, 8 minus 1 is 7. Remember for the t-test. Since we're only using one, we really have only one sample, which is all the differences. So this is really a one sample t-test because the differences have already been calculated for us. So t is x bar minus mu over s over the square root of n. Okay, we've done this a lot of times. So then plugging all this in, negative 83.375 minus the hypothesized differences over the standard deviation over the square root of 8. And when you calculate that all, that's negative 2.01120, which we round to negative 2.011. Well, what do we do with that? Well, we're going to compare it to the critical t using alpha and the ALEKS calculator. So this is a left-tailed test, and alpha was 0.01 from the original problem. So ALEKS gives a right-tailed test. If you hover over this key, it'll show you the picture of what the return is going to be, and the return is the t-value, but for the area to the right of the critical value. Well, we need a left-tailed test. So first, we're going to subtract your alpha from 1, and we're going to actually plug in 0.99 instead of the 0.01. So plugging that into ALEKS, you get 0.99, and the degrees of freedom was 7. So the critical t that you get back is negative 2.9979. So our test statistic was negative 2.11. Our critical t was negative 2.998. So here is the rejection region is at negative 2.998. But our t was over here at negative 2.011. So that is not in the rejection region. So we fail to reject, okay? So we cannot reject it, otherwise in other words, the owner cannot conclude that the mean sales of store 2 exceeds that of store 1.